Kubernetes stacks meet RAG reality. The open-source Kubernetes ML stack is coalescing around pragmatic choices. Start from proven foundation models, adapt them safely, and ship with reproducible tooling. A curated list emphasizes Hugging Face Hub as the default source for licensable, well-documented models like Llama, Mistral, and Stable Diffusion, paired with standardized model cards and APIs to keep teams honest about capabilities and constraints. Cloud provider catalogs, GCP Model Garden, AWS Model Zoo, Azure Model Catalog offer optimized builds with SLA-friendly performance on AKS, EKS, GKE, but come with lock-in risks via proprietary accelerators, Neuron, TPU, and hidden egress costs. Useful escape hatches if you're already deep in those ecosystems. For interactive work, Kubeflow notebooks bring Jupyter to Kubernetes with GPU fairness, persistent volumes, and data lake connectivity, while MBDev treats notebooks as versioned, testable code to avoid hidden state traps. Even Julia gets a nod via reactive Pluto JL for dependency-aware execution. Retrieval augmented generation, RAG quality hinges on ranking the right passages. A new re-ranker leaderboard compares models by LO, accuracy, and latency, and the maintainer is actively adding community-requested baselines like BGE and Qwen3 re-rankers. The discussion also notes gaps in current benchmarks. Datasets with very high or very low recall can mask differences, so diversified test suites matter. There's an open-source evaluation harness if you want to run your own data. It's an overdue service. Many projects defaulted to Cohere only to find cheaper or better cross-encoders later. On the first stage retrieval side, late interaction models are edging toward best of both worlds. LFM2 Colbert 350M claims bi-encoder scale retrieval with re-ranker-like expressivity, and critically, multilingual and cross-lingual strength. Store documents in English and retrieve in German, Arabic, Japanese, or Korean with high NDCG at 10 on an extended nano-Bayer benchmark. Results beat a GTE modern Colbert baseline when queries and docs are in different languages. It's designed for drop-in use in RAG pipelines and ships with PyLate for indexing, FastPlad. Codebases documented by agents. Repository-level documentation automation is getting more serious. CodeWiki proposes a semi-agentic framework that statically analyzes code with TreeSitter, builds dependency graphs, identifies architectural entry points, and recursively partitions modules so specialized subagents can document complex parts without losing cross-module coherence. The team introduces a benchmark, CodeWiki Bench, to assess repository-level docs and reports average gains over Open DeepWiki implementations, plus 4.73% overall with 18.54% on TypeScript and plus 9.41% on Python across 86K to 1.4 memlock repos. The focus here is architectural understanding rather than one-pass summaries. The evaluation is research-backed, though the community rightly asks for side-by-side outputs. Meanwhile, AI-assisted coding workflows are flattening the distance between spec and working repos. One practitioner describes using Claude Code Web as a primary jump-off point. Write a clear Markdown specification, commit to a blank GitHub repo, and get a production-ready project scaffold. Rust core, NAPI bindings for NPM, TypeScript interfaces, CLI, CI pipelines, and even MCP servers for AI integration without touching IDEs or local toolchains. That's one user's experience. Not a benchmark, but it captures where integrated cloud coding is heading. And yes, MCP here means Model Context Protocol. Even vertical tooling is turning minutes to prototype into a baseline promise. A website builder powered by Claude AI claims full site generation in minutes, light on details but emblematic of the rapid commoditization of boilerplate-heavy tasks. Universities are wrestling with the downside, vibe coding. A Hackaday report relays students' complaints about peers who rely on AI enough to produce code that looks polished but often doesn't run. Skill acquisition is the casualty. The piece draws a useful line between knowledge, recoverable later with reading, and skill, earned through doing, citing paper-based programming exams in some countries as a blunt countermeasure. The workplace will adjudicate soon enough, but the signal for educators is clear. Separate demonstration of understanding from demonstration of ability. Agents from orchestration to learning. A new entrant in multi-agent orchestration, Ladder, asks the community to break it. The framework emphasizes modularity, from the LLM per agent to pluggable message buses, Redis, Kafka, and long-term storage for traces and memories. It exposes agents as microservice-like components, offers a dashboard and playground, and claims production readiness without requiring deep infra knowledge. The reception mixes curiosity with healthy skepticism. The project and domain were just registered, but early code quality looks decent, and observability gets high marks. The question, what's truly better than LangGraph or Crew AI, remains open until it's battle-tested. On the learning side, a coding agent trained with reinforcement learning at scale, 32 to H100s across 4 nodes, improved a Qwen 314B orchestrator from 7% to 18.25% on Stanford's terminal bench, now in striking distance of a much larger Qwen 3 coder 480B at 19.7%. The biggest operational lesson is surprisingly simple: reward unit tests and avoid smart reward shaping, which caused policy collapse. The author also stresses that RL for agents is painful and not a shortcut. For most workflows, prompt engineering atop SOTA models still wins on cost, speed, reliability. All code, weights, and datasets are open-sourced. A research direction called Early Experience offers a middle ground between imitation learning and full RL. Instead of waiting for clean reward signals, agents learn by acting to collect future states and then predicting them, implicit world modeling, and by self-reflecting against expert trajectories to identify suboptimal decisions. Across 8 environments, from embodied and web navigation to tool use and long-horizon planning, authors report average absolute gains of plus 9.6 success and plus 9.4 out-of-domain generalization over SFT-only baselines, with additional boosts when initializing RL from early experience checkpoints. It's positioned as a practical bridge, more scalable than expert-only SFT, and a stronger warm start for later RL. Post-training precision and reasoning. Post-training is undergoing a rethink. Trajectory distillation, sampling student trajectories and having a strong teacher grade each token, aims to compress reasoning structure rather than parameters. Reported results from the on-policy distillation line claim Qwen 3.8b reaches 74.4% on AIM24, matching RL pipelines at roughly 10 times lower cost, with stable learning and recoverable instruction following after domain-specific mid-training. The field is competitive and nomenclature is still settling, but the appeal is obvious: dense supervision without fragile RL credit assignment. A separate, concrete lever: precision. Precision RL finds that training in FP16, not BF16, reduces the training inference mismatch and stabilizes RL across algorithms, RPO, GSPO, etc., model families, R1D, Qwen, OctoThinker, and scales, dense 14B, MOE. The team provides a minimal patch to enable FP16 in VRL and replicates across frameworks. It's a reminder that sometimes systems-level dials move the needle more than new algorithms. Architecturally, not all reasoning needs to talk. A 27M parameter model built from 2 coupled recurrent networks, one updating every time step, the other every T time steps, resetting the first, solves hard puzzles like Sudoku and maze navigation with just 1,000 training examples, while large language models reportedly get 0% on the same tasks. Training back-propagates only through final states to keep memory constant, even for hundreds of steps. Enthusiasm is tempered by fair questions. Recurrent designs align well with these tasks. Broader generalization remains to be shown. Still, it's a pointed demonstration that internal iterative computation can beat token-by-token narration on certain reasoning problems. New model families are also exploring mixture and diffusion ideas. LADE 2.0 Flash Preview is a 100B MOE diffusion language model with just 6.1B parameters active per inference step, targeting strong code and math performance and tool use. It reports high scores on GSM-8K and human eval, publishes detailed sampling settings, and is Apache 2.0 licensed. The team plans RL fine-tuning to supercharge reasoning, but for now it's an instruction-tuned preview, not a full production release. Security mishaps and defenses. Operational hygiene was on display this week. Microsoft acknowledged a Windows update causing BitLocker recovery prompts on Windows 11 25H2, 24H2, and even Windows 10, mostly on Intel PCs with modern standby S0 low-power idle. A fix is rolling out, but admins may need to deploy it manually. Backing up recovery keys remains the safety net. The same October 2025 wave also broke mouse keyboard in WinRA, since patched. disabled File Explorer's preview pane to mitigate NTLM attacks, and introduced a task manager quirk requiring end task to close duplicate processes. Defaults matter. An employee says the password to the Louvre's video surveillance system was Louvre. No further analysis is needed to file that under Don't Do This. At the other end of the spectrum, Operation Chargeback shows what coordinated defense looks like. Authorities across Europe and beyond targeted 3 major fraud and money laundering networks accused of misusing stolen credit card data from over 4.3 million cardholders in 193 countries, with damages exceeding $300 million. The scheme allegedly created 19 million fake subscriptions on websites, pornography, dating, streaming, designed to avoid indexing, used low, obscure charges to evade detection, and laundered funds via shell companies in the UK and Cyprus. Notably, suspects include executives and compliance officers at payment providers accused of collusion. Assets worth over $35 million were secured. More actions are pending. People and process are still the weakest links. A LinkedIn post warns that click a link on the web, leak documents, is not hypothetical. Link-based data exposure remains endemic. Having tooling to instrument HTTP flows helps. RecTap is a cross-platform zero-dependency CLI request black hole and webhook debugger that returns immediate 200 OK, streams requests via WebSocket to a dashboard, filters by method path headers IP, forwards with retries backoff, and exports JSON CSV. It's useful for seeing exactly what your browser or service is sending and where it's really going. Edge LLMs in the homelab. For DIY agents and RAG at home, the best advice is still experiment before you spend. One homelab thread begins with a 16-gig Radeon 6900 XT workstation and an always-on file server, then explores options from CPU only to added GPUs. Community guidance is pragmatic. Try your current GPU with Ollama, or better yet, llama.cpp on Linux, often 2x faster than Ollama in practice. Learn the limits, then buy hardware that fits your actual models. If you must, even a modest RTX 4060 Ti can handle 14B class models. Loading is slower due to memory bandwidth, but inference is workable. Virtualization helps you break things safely. A hypervisor like Proxmox with GPU pass-through to an Ubuntu VM keeps an always-on service stable while you tinker in containers. If hardware is uncertain, rent cloud GPUs to validate your workloads first. The last thing you want is to discover a card can't run the quantization or context windows you need. Multi-GPU dreams come with caveats. Mixing vendors is thorny, and you'll be bottlenecked by the slowest card. PCIe lane constraints, e.g. X4 slots, can hurt throughput. Some iGPUs aren't supported by common inference stacks, and Windows can complicate things compared to Linux. If you're integrating with agent platforms like N8N, make sure your chosen inference library is supported. Users note they haven't yet wired llama.cpp directly into N8N.